Pap, mag jouw geluid zo uit? Top. Hallo. Ik ga over 1 minuut mijn college geven. Dus dan, ja.
Mag ik dan wat komen eten?
Ja, ja, heel zachtjes.
Nou, het was er inderdaad wel aangenaam.
All right, guys. Hi, and welcome to the third webinar of our statistics prep course throughout the summer of 2020. I'll wait for 3 more minutes for extra people to join, and then I'll get started. But good to see that you're here. So hi to Isabel for just joining. I'll wait for 2 more minutes until it's 2:05, and then I'll get started. All right, it's 5 minutes past 2, and that means that I'd like to get started. More people might join later on, but for now, that's not a problem. First of all, I would like to applaud you guys, everybody who's taking part in the summer campus, for actively making the time and doing this statistics prep campus, because it's currently summer. Most of you have had a very long year and need your summer break, and that you then spend the time on working on this statistics is, in my opinion, a very good asset. It really shows how motivated you are. And I think that if you are going to do a quantitative thesis at the end of the upcoming year, or maybe after 2 years, depends on how long you take for your master's, it will really be helpful. But good job on all of you, even those who did not start yet, but will start later this week or start in a few weeks from now. Whenever you make the time for this, it's really helpful. And I think that you're doing a good job, that you're taking your master's seriously. And if you keep taking your master's that serious, then I don't doubt that all of you will eventually graduate with a nice mark. Okay, so what I'd like to do for today is, because it's really, really warm in the Netherlands, I don't know whether you guys, I know from some people, like for example, Isabel, that she's Dutch, but some other people probably still live in their home country and will be arriving in the Netherlands later this month. But over here it's really, really warm, so I'm not gonna make it extremely long. What I would like to do for today is first answer a few previously asked questions, and then ask whether you guys, the active participants, have questions, and then I'll call it a day. So I don't know how long it will take exactly. The first question, which I got quite a lot, is is in chapter 2, about the correlation, and it's about the relationship between the weight slash the size of a car and the gas mileage. And most people thought that if the weight of the car increases, then the gas mileage increases, but that's not true. Gas mileage means how many kilometers or miles you can drive with 1 liter of gas. So if your car increases, that means that it takes more gas to drive 1 kilometer. So therefore, the amount of kilometers you can drive with 1 liter of gas decreases. So therefore, it's a negative correlation. So the bigger the car, the less gas mileage. If you struggle with words like mileage, then look them up. There's no shame in visiting an English dictionary. Even I do so sometimes. The second question was regarding alphas. The alpha is what you compare the p-value with. Most of the time, also in your thesis, you'll probably be using an alpha of 0.05. So if the p-value is lower than 0.05, that means that you can, that means that your hypothesis is, your nil hypothesis is false, and you can accept the alternative hypothesis. But note that throughout this course, sometimes they have changed the alpha value. So sometimes that it is 0.04 or 0.1 or 0.01 even. So make sure that you take a specific note of which alpha you need to compare the p-value with. Then first of all, it's quite basic, but still some people seem to struggle with the difference between a mean and a proportion. The mean can be any number, and it's like a specific value. For example, how many liters the average person drinks a day. That can, for example, be 2 liters a day. Or how many times people go on vacation every year. That can be like 1.8 or something like that. Or the average amount of citizens in an English city will be around 50,000, something like that. So those are all means. So they are like whole numbers. While a proportion is like a percentage, and it mostly belongs to categories. For example, there's people who prefer Coca-Cola, there's people who prefer Fanta, and there's people who prefer Sprite. And then if 40% would prefer Coke and 30% would prefer Sprite and Fanta, then the proportions would be 0.4, 0.3, and 0.3. Or for example, if you assume that there are 2 major parties, for example, the Democrats and the Republicans, and that they would get the same amount of votes, so both would get 50%, that would mean that the proportions are both 0.5. So proportions are always between 0 and 0.1. and 1, with 0 being 0% and 1 being a full 100%. Make sure you know this difference. It's the basics, but as I always say, statistics starts with the basics. If you don't understand this, then you'll struggle later on. So always make sure that you take enough time to get to know your basic information. And then fourth of all, it goes into chapter 6 and 7. And I'd like to make, there's a lot of theory on one sample t-tests, independent samples t-tests, and dependent or paired sample t-tests. And I'd like to quickly, I'm not going to explain how you do them. I think that the theory on sowieso is quite elaborate. Furthermore, on the top of every theory page, you can find links to YouTube videos, and the ones for the one sample t-test, independent samples t-test, and paired samples t-test, I think are all from me. So they go back to one of my YouTube videos in which I explain it. So I'm not gonna do the same today because you can just watch my YouTube video. But I'd like to explain briefly the difference between those three samples, between those three t-tests. With the first one being a one sample t-test, that means that you compare the mean of your research. So for example, with the population mean or a previously known mean. Let's for example say that the population mean of how many liters of water you drink a day is exactly 2 liters a day per person. And let's say that you do the exact same research with a smaller sample of, let's say, 1,000 citizens, and you find out that the mean is 2.4 liters. And you want to know whether that statistically differs. So you want to know whether the mean from your studies significantly differs from the population mean or a previously known mean. And that's when you use a one sample t-test, because you only have one sample, which is your research, and you compare it to a general known mean. So that's a one sample t-test. It can also be that you want to compare two samples. For example, you want to compare men and women on how many liters of water they drink a day. They can either use the independent samples t-test or the dependent, also more, which is also known as the paired samples t-test. And you need to ask yourself the question: are these two groups related? Do they influence each other's answers? And for example, if you would take your total research has a amount of respondents of 1,000, let's say 500 men, 500 women, and you want to compare those means. For example, men drink 1.6 liters of water a day, and women drink 2.5 liters of water a day. And let's say you want to compare these two numbers. Men and women don't influence each other's answers. There's no relationship. There's no way those answers can influence each other. So therefore, it's an independent t-test. However, when you compare the same group over time, let's for example say that you want to compare the group of men on a day in which they don't do any sports, and then measure how many liters of water they drink. Let's say, for example, 2 liters. And then the next day, you take the same group of men, you let them sport throughout the whole day in the summer, and measure how many liters they drink then. And that's, for example, 3 liters on average. If you want to compare the same group 2 times, that group is influenced by each other because it's the same group measured multiple times. So that means that the 2 groups are related. And that's when you use a paired samples t-test. So always ask yourself the question: do you have one sample and you compare it to a population mean? Do you have 2 unrelated groups, for example, men and women, or first graders and second graders in a school? Or then it's a independent samples t-test, or is it a group which is or are 2 groups which are related? And in your studies, that will almost always be the same group measured twice throughout time. So that's the same group measured twice. Then it's a paired samples, or in other words, a dependent samples t-test. And that's the major difference between the different kind of t-tests, and how you need to perform them is explained very broad on sowieso and in my YouTube video, and you can practice endlessly. You do need Excel or a graphical calculator to calculate that. But yes, that's what I wanted to explain for today. Those the three questions before were the most often asked about the gas mileage, the alpha/p value, and the difference between a proportion and a mean. Do the guys which are present in this webinar now have any questions? Then now is the time to ask it in the chat. And if there are no questions, then also feel free to say that. Okay, I don't think that there are any questions. Okay, then last but not least, because I have some time left, I'll explain once more very quickly the difference between a normal distribution and normal norm.inv. Wait, what's the exact name? 1 second. Yeah, between norm inverse, normal distribution, and normal inv. I think it stands for inverse. Correct me if I'm wrong. Normal distribution is used for when you want to calculate a chance, so a probability, so a p-value. You have to know the mean and the standard deviation and a certain x value. And if you insert that in the normal distribution, then you get a p-value between 0 and 1. So a normal distribution is used to get from an x value to a p-value. So from a certain number to a p-value between 0 and 1. Normal inverse, I think, or norm.inv, at least that function, is used the other way around. You know the p-value and you want to get to a certain x value, which in this course is almost always, if not always, to calculate a specific z value. So for example, you know that you want, if you want to know how many z values, so how many standard deviations are necessary for a certain confidence interval, then you do norm.inv and then the confidence interval plus 100. So for example, 195, then epsilon 1, which is the epsilon 0, epsilon 1, which are the mean and the standard deviation. And then you get the z value. So it's the other way around. It's you want to know the chance, because the confidence interval is always a chance. So then you go from the chance to an x value with norm.inv, while with normal distribution it's the other way around. You go from an x value to a p value. And that's in short. I also already explained this very more extensively on WhatsApp, in the WhatsApp group, but I've now explained it over here as well. So those who didn't want to participate in the WhatsApp group also had now a very brief explanation. If you have any further questions on that, please leave a question in the forum on Sowieso, or email me or send me a WhatsApp message, and I'll try to get back to you as soon as possible. This means that it was a very, very brief webinar, but I think that due to the weather, that's not a bad thing at all. And it means you guys don't have a lot of questions, which is a very good thing, because it either means that you're either really smart. One question: the solutions of the exercises never explain how to use a graphical calculator, but you have to use normal CDF and inverse norm, right? Yes, yeah, you do. Yeah, throughout this course, it only shows how to do it in Excel. But if you want to do a graphical calculator, you can use inverse norm is definitely right. And normal CDF, I think, is also right. It also calculates the difference. Or else you just need to Google that really quickly. There's tons and tons of explanation on that. But I wish you guys the very best of luck with the remaining phase of this prep campus. It officially ends upcoming Sunday, but you can always work on it longer. After Sunday, I'll answer questions less frequently. I try to answer them now on the same day, but after Sunday, I'll answer them less frequently, but I'll still check the messages every once in a while, no worries. So I wish you guys all the best throughout the rest of this prep campus, and moreover, on your masters. I hope you enjoy your masters, that it's fruitful, that it's interesting, and that you guys really get the most out of it. And let me know at the end of the year when you're working, or if you do a quantitative thesis, let me know whether this basic information was helpful. And I now see that I get another question. The formula norm.inf, and then between brackets c plus 100 divided by 200 epsilon 0 epsilon 1. Why is the mean 0 and the standard deviation 1? Well, the easiest answer for this is it's always like that. So you never need to think. If you're using the normal inverse function, the mean is always 0 and the standard deviation is always 1. Because you're using it to calculate standard deviations. And the mean, so let's for example say that the mean of liters of water, how many liters of water you drink a day is 2. That is the mean. And then you can go standard deviations to the left or standard deviations to the right. You use normal inverse, yeah, correct. I don't know the exact name, norm.inf. You use that to calculate how many standard deviations you need to go to the left or the right. The mean is 0 standard deviations from the mean. That's why it's 0. So it's always calculated in standard deviations. And the mean is, of course, 0 standard deviations from the mean, because it is the mean. And 1 standard deviation is 1 standard deviation, because you're calculating in standard deviations. So that's why the mean is always 0, because it's 0 standard deviations from the mean. And you're calculating in whole standard deviations. So the standard deviation is always 1. Good question, actually. Very, very good question, Agnes. Thanks for asking. Are there any further questions? Then now is the time to ask. Okay, then I don't think there are any. Then I wish you guys the best throughout the rest of this prep course and your masters, and enjoy this sunny summer weather. And I hope to see you guys again sometime in the future. Ciao.